Hello everyone, welcome back to the Lee County Library Science Club. It's great to have you with us once again. I just want to remind everybody that there may be a tad bit of risk involved in these experiments, so make sure that you have your parents' permission and their supervision when doing these experiments. Now today we are going to create our very own rainbow. Won't that be wonderful? However, we're not going to make it the way you normally would by refracting light. Instead, we're actually just going to use the colors of the rainbow to demonstrate one of the more important concepts from chemistry and physics, which is density. Density means just how much stuff is packed into a space. Here on Earth, within our atmosphere, there are molecules basically everywhere. But depending on what those molecules are and in what phase they are, well, they can behave differently and they may take up more space or be more spread out or more compact. Okay? For instance, this book has a lot more molecules stuffed into a small space than, say, all the air around me. Now, how do I know that? Well, if I hold this out and let it go, it falls right through the air, doesn't it? Which means that gravity is acting on this book more strongly than it is on the air around it. And that's because the book has a higher density, or there's more stuff in here for gravity to pull on. Now, mathematically, this is defined as density equals mass divided by volume. Mass is a little bit of an odd concept. It is similar to weight, and we usually define it by weight, but it's different because the weight of something may change depending on how far away it is from the Earth and how much gravity is acting on it. But mass doesn't change. Mass just means how much stuff something has. Alright? Now volume, that's pretty self-explanatory. Volume is just how much space there is. For example, you might have something at home like a 5-gallon bucket. Well, the volume of that bucket is 5 gallons. That's just what it means. So if you have more mass that you can stuff into a smaller volume, that will give you a higher density. And on the other hand, if you spread something out, okay, fewer molecules over a larger area, well, that makes a lower density. Make sense? We are going to demonstrate how density works and how substances of different density interact with each other by creating different solutions of sugar and water. A solution is defined as a homogeneous mixture of two substances. Now, homogeneous is just a fancy word that means they're mixed evenly and they won't separate out on their own. In contrast to that, a heterogeneous substance is two particles that are mixed, but they don't actually intermix evenly. And that creates something like an emulsion, for instance, which is what milk is, where you actually can see like the different particles in it. That's why milk is cloudy, because you're seeing the particles that are not dissolved in the water. It's a heterogeneous mixture. And today we are instead going to be using solutions which are homogeneous. One of the key factors of solubility, or the ability to create a solution, is polarity. Now obviously we've talked about polarity a lot lately, and we know that water is a very polar molecule. In chemistry and physics, water is known as the universal solvent. It is used in all kinds of different solutions as kind of the base, and the thing that you mix other stuff into is water, because it is such highly polar molecules that mix together and make good solutions. So these sugar molecules have to be polar as well, right? And they are because all around the outside of a sugar molecule are what are known as hydroxyl groups. A hydroxyl group is one oxygen molecule and one hydrogen molecule. They're bonded together and then bonded to another part of the molecule. But because we have that hydrogen and oxygen together, that hydroxyl group ends up with a negative charge. And so obviously if it has a negative charge, then it can interact and intermix with the positive and negative charges of our water molecules. So what we are actually going to do is create 6 different solutions of the sugar and water by having a different concentration of sugar in each cup. Now I have about a half cup of water in each of these glasses, and obviously I've already prepared my colors, and I tried to do pretty much our rainbow colors. But when you do yours, you feel free to make whatever colors you want. Just make sure you can actually tell the difference between them. Alright? In our first cup, we're going to do just water. No sugar. It's all water molecules in there. About a half cup of water. Okay? Our next one, we're going to have the same amount of water, but we're going to add about a teaspoon of sugar to it. Okay? And then the second one is going to be 2 teaspoons of sugar, and 3 and 4 and 5. So what we're going to end up doing is we have the same volume of water in each of our cups, but because we've dissolved sugar into them and a different amount of sugar into each one, then there's a different mass to each volume, right? So this one should have our lowest density because it's just the water molecules. And then this one should have our highest density because we've packed a whole bunch of sugar molecules in between the water molecules, right? So once we've got them there, we're actually going to put them all together into a different container so we can see how the different densities interact with each other. Ready? Now to start this, obviously, you need 6 glasses and some water in each one. You'll need some food coloring. As I said, I've already prepared mine, but definitely do your food coloring however you really want to. Just be careful. It can stain clothes sometimes if you drip it the wrong way. We need some sugar. We need a spoon or teaspoon. And you'll need some kind of tall, thin container. Alright, this here I have is a vase, but if you have a tall, thin glass or even a beaker, that would work well. And then you'll just need something to move the water with. Okay, maybe a turkey baster or an eyedropper. This I have here is just a child's medicine dropper. Alright, something that we can move the water a little more gently than just pouring it. Now, as we said, we're just going to leave our first one just water. We're going to go to the second one. Put a spoonful in. Okay. Next one, we're going to do 2. And actually, I'm going to go ahead right down the line and add all my sugar in. Now I'm going to go down the line and mix them all up. And you want to check in the bottom to see, make sure there's none left down there on the bottom. We want it all dissolved in there so we can really be sure that we have different densities, okay? You can see right now some of these other ones, the sugar has settled to the bottom. So we want to mix them up really well and get that sugar all the way mixed. If it's not perfect and there are a few grains of sugar left at the bottom, that's fine, not a big deal. We just want to make sure that we really got as much as we can mixed in. Okay? So, we're going to start with our highest concentration of sugar, which should be our highest density. In my case, that's going to be our red. So I'm going to get some red in my dropper here. Put it at the bottom of the vase. Next I'm going to get some orange. Now when you add these subsequent colors, don't just squirt it right in there, okay? Because if you squirt it in there, you're going to agitate it and their solution is going to start to mix and it's actually going to start to balance out instead of keeping different solutions. So I'm going to tip it and just kind of gently run the orange down so you can see it's kind of settled on top of the red a little bit. Next we've got some yellow. Again, I want to do it nice and gently, just a trickle, so that it doesn't mix together and compromise our solutions. Alright, now if you look at it, we've got a little bit of a rainbow going on, don't we? Now our bottom ones have mixed together a little bit, and I think that's partly because our colors were really close together. Like we said in the beginning, if something has a different density, then gravity is actually going to work on it differently than it would on something of a different density. Alright? So because the red has the highest density, there's the most stuff or the most mass in here for gravity to pull on. So therefore it's going to be pulled to the bottom. Okay? Now our purple has the least amount of mass in it, and so because gravity's working on them all at the same time and they're in an enclosed space, it can't actually pull the purple past the other ones because it's pulling on the other substances harder because they have more mass. Okay? And that is how density works. Now, why is that important? What do we care about density? Well, in a simple way, density is what lets us and boats float on the water. Because in a ship, there's so much air space inside a ship that the overall structure has less density than the water it's sitting on top of. And therefore, it floats on top of the water. And as I said before, density is also used in all kinds of different chemical reactions. It's also important in a more everyday economic sense in that the density of things helps us know the easiest way to transport them or move them. And it even can contribute to things like gas prices can be dependent on the density of the petroleum. Thank you so much for coming. We hope you enjoyed it, and we'll see you next time. Bye!